Hello, my name is Carmen Bartleson. I'm an undergraduate student at West Virginia University studying biomedical engineering. Today, I'm presenting research on the role of PDGF-BB and the inflammation of mice lung microvasculature after e-cigarette exposure. An e-cigarette device heats and vaporizes a liquid made of nicotine, propylene glycol, vegetable glycerin, and flavoring. This is a diagram of the general setup of an e-cigarette device. It has a mouthpiece, a coil chamber, a heater coil, a wick, and the nicotine-containing liquid, which is then vaporized. E-cigarettes typically are perceived as a safer alternative to conventional cigarettes, but increasing evidence suggests that this technology leads to the activation of inflammatory cells and lung injury. Recent research has also shown that a type of biomarker, PDGF, which is short for platelet-derived growth factor, was elevated in the plasma of e-cigarette users. As the figure below demonstrates, we hypothesized that the e-cigarette vapor injures the circulatory system, which recruits and activates platelets. These platelets release PDGF. The PDGF then bind to surface receptors on neutrophils, consequently activating the NADPH oxidase pathway, or NOx for short. This pathway generates reactive oxygen species, which provoke neutrophil extracellular traps, or NETosis, and inflammatory responses. Male and female mice were treated with e-cigarette vapor for up to 9 days. The first group, the e-cigarette exposed group, received 150 puffs for either 3, 6, or 9 days. The control group of mice was treated with room air. The positive control received PDGF. The negative control received imatinib mesylate, which blocks PDGF signaling. And the final group was exposed to e-cigarette vapor coupled with imatinib injection for 9 days. The figure below shows the setup for e-cigarette vapor exposure for the mice. The day following e-cigarette exposure, lung intravital microscopy was performed to analyze lung inflammation. The fourth figure shows the general setup and procedure for intravital imaging. Collected lungs were used in multiplex fluorescent immunohistochemistry and protein mass spectrometry. For IHC, we froze mice lungs and sliced them with the cryostat machine. We're still working on staining the slides, but then once all the slides are stained, they'll be imaged to be analyzed. Lastly, to analyze the change in cytokine expression, a proteome profiler mouse cytokine was performed. The results from lung IVM revealed a significant increase of neutrophils and neutrophil platelet aggregate areas in the e-cigarette groups when compared to the room air groups. A higher response of platelet activity was detected in female mice. This is likely due to the menstrual cycles in females. PDGF groups were not found to be significantly different from the 9-day e-cigarette vapor groups, and this helps to reiterate the role of PDGF in inflammatory responses. The greatest difference of an inflammatory response was seen in mice receiving imatinib or imatinib plus e-cigarette vapor when compared to the 9-day e-cigarette vapor groups. This just indicates that imatinib treatment blocked aggregate formation in the e-cigarette exposed mice. The results of the cytokine array indicated upregulation of 9 pro-inflammatory cytokines in male e-cigarette mice. However, all except for 2 of these same cytokines were downregulated in female e-cigarette mice when compared to the room air groups. Immunostaining and mass spectrometry results are still currently in progress. And through this research to explore the pathway in which PDGF contributes to lung inflammation post e-cigarette exposure, we hope to educate the public about the dangers of e-cigarettes. Thank you for watching.